Again, welcome to DSRT 734 class. In this lecture, we're going to continue with our normal distribution. In the previous lectures, we learned how to find the probability when the mean of the data is given and also the standard deviation is given. And we were told to find the probability of X value given X value. This time we are going to find the values, just such as Z and also the X. So again, in this section is a normal probabilities, finding values. So our main objective is to find a Z-score given the area under the normal curve. Also how to transform a Z-score to an X value. As we said earlier, the previous lectures, we learned how to find the p-value when there's X is given. So when X is given, we can find the Z value as far as we have the mean and the standard deviation of the data set. Then we can go to the standard normal table or the Z-score table and get the p-value. This time the p-value is given, and we can still go to the table, the Z-score table, and find the p-value. So let's start first. So we said that again in session 5.2, that's our previous lecture, we were given a normally distributed random variable X, and we were asked to find the probability. So we know the X value, and we were asked to find the probability. As far as the mean value is given and the standard deviation is given, then we can transform X to Z. We can find the value of Z. When we know the value of Z, we can find the probability. And that's what we did in the previous lectures. Now this time we are going to do it opposite. The probability is given. It can be given in percentage or in the decimal number. If it's percentage, again, we just change it to a decimal number or divide the value by 100. So if P is given, yes, we can go back to the table and find the Z. Then from the Z, we can find the X. So let's see an example. So here the question is given, they say we should find the Z-score given an area. So find a Z-score that corresponds to a cumulative area of 0.3632. So cumulative area of 0.3632 is our p-value, and it looks something like this. So we have our normal curve, and the area for 0.3632 is given. So our goal is to find a Z value. So since we know the p-value, we can go to the table, and then we look for the p-value in the table. So here, the p-value, closest value is 0.3632. So this means the Z value will be negative 0.3. That's the negative 0.3. Then the next decimal place is 5. So the answer will be negative 0.35. So here we say again, negative 0.35 will be our Z value. Another question is given the same example, but this time the area is given to us in percentage. So here they say find a Z-score that has 10.75% of the distribution's area to its right, this time to the right. So this means first we change the percentage value to decimal. So that will give us 0.1075. Then when we drew the normal curve, they said to the right. So the area is 0.1075 to the right. And we know that in our table, always we find the value of the P or the Z always from the left. So the P value is from the left. So this means we are going to, in order to get this answer here, we are going to subtract the value 0.1075 from 1, and that will give us to the left. So this means we are going to use 0.8925 to find a Z value, because in the table, the values are not from the value to right. So it's the the value to the left. So we go to our table and we look for 0.8925, and that gives us 1.2 to the left, and to the top is 0.04. So our z-score will be 1.24. Okay, so the next, let's say we should find the z-score that corresponds to P5. So we assume P5 is 5% to the left. So the z-score that corresponds to P5 is the same z-score that corresponds to an error of 0.05. So we have the error of 0.05. Again, since this is to the left, we go straight to the table, then we find the result. So here we say the area closest to 0.05 in the table is 0.0495, which is okay, almost 0.05. So you look at the table, to the left we have negative 1.6, at the top we have 0.05. So the answer for the Z will be negative 1.65. So again, what we just did right now, the goal is to find only the Z value. So P is given to us and we find the Z. Now we are going to transform Z score to an X score. So this means if P is given, I will use the P to find Z, and later I will use my Z score formula, transform it to X equal to mu plus Z alpha. This formula was derived from Z equal to X minus Z over standard deviation. When we transform the formula to find X, this is what we get. Because again, we have Z equal to mu X minus mu over standard deviation. So cross multiply, we can see that the Z will multiply the standard deviation. So standard deviation multiplied by Z equal to X minus mu. When minus mu cross the equal sign, become plus. So we get mu plus Z standard deviation, which equal to X. So from this formula, when we look at our question, we don't have the values. We don't have the values. We are looking for X. First thing we need to find is the Z. So here, the example is given: the speed of a vehicle along a stretch of highway are normally distributed with a mean of 67 miles per hour, standard deviation of 4 miles. Find the speed S corresponding to the Z score, first of 1.96. So when we write the formula down again, as we said earlier, we don't have the Z value. So we know the P. So the same first examples we have, if I know the P, I can find the Z. So the P 1.96, when I look at my table, I mean the 1.96, when we look at the table, this is what we get. So now we know X will give me 67 plus 1.96 times the standard deviation was given to be 4. Again, the mean is 67. So we have 67 for mean plus the Z is 1.96. Standard deviation is given to be 4. So our final answer for X will be 74.84. The same thing we can find when Z is negative 2.33. The mean is the same value, 67 plus. This time the Z is negative 2.33 times the standard deviation, the same value, 4. And by doing these calculations here, we get 57.68. And the last is when Z is 0. So when Z is 0, our X is the same as the mean. So now the next example says we should find a specific data value. So here we have scores for civil service exams are normally distributed with a mean of 75 and a standard deviation of 6.5. To be eligible for civil service employment, you must score in the top 5%. What is the lowest score you can earn and still be eligible for employment? So this means we are looking for the X value. So we know we are top 5%, which means if I'm looking for the Z value, I'm going to use 95%. Top 5% means to the right, 5% to the right. So the remaining will be 95%, which is 0.95. So we can see that that is the first thing we do. An exam score in the top 5% to the right, top 5%, is any score above 95 percentile. So we find a z-score that corresponds to a cumulative area of 0.95. So now we get a z-score to be, again, from the table. I'll look at 0.95 p. What is the corresponding value for the z? To the right, it should be 1.6. At the top should be 0.04. So our answer will be 1.64. Or if we use the value 0.9505, the z stay 1.6 and the next value to the right, so the column 0.05. Now, because 0.95 is halfway between the two areas in the table, we can use the z-score that is halfway between 1.64 and 1.65, which will give me 1.645. In some textbook, I may decide to use either 1.64 or use 1.65. Here, since the value for 0.95 fall between 0.9495 and 0.9505, we just decided to find the average of the two. So now we know the z-score. If we know the z-score, we can find the x value. So the x will give me, the mean is given to us to be 75. We just find the z-score to be 1.645. And the standard deviation again is 6.5 somewhere. Let's go back to the question. So standard deviation is 6.5, and then the mean is 75. So we are using those two values here. The mean is 75, standard deviation is 6.5, and this is where we find the average for the z value based on the p value in the table. So we get 1.645. So here we say the lowest score you can earn and still be eligible for employment will be 86, because we get the x value. Because here we say the top 5%. So we have to use the x value, the z value at top 5%. When we know that, we can find the x value. Because the mean is given, the standard deviation is given. So what we need is the z value, but p is given. So we use the p to get the z value. Then after that, we find the x. So this is the summary of our lectures in normal distribution. Again, our first global distribution lectures, we learned the theory behind normal distribution and what is also standard normal form, where we say again the mean is 0 and the standard deviation is 1. From there, we move to the second lecture of normal distribution, where we learn how to find the probability of normal probability distribution. So most of the time, they will give us the standard deviation of the data set and also the mean of the data set. Then we can find the z-score. When we get the z-score, we go to the standard normal table or the z-score table, and we find the p. In these lectures, they gave us the p, and they told us to find z. And another question, they gave us the p, and they say we should find the value. So if p is given and we have to find, again, z, we use the same standard normal table. This time we look inside the p value to look outside corresponding location, will give us the z value. Now, if I know the z value and the standard and the mean is given and the standard deviation is given, I can find the x value or the random variable value. So that's what we cover in this section. So again, wish everybody the best and thank you.